The de Havilland Comet was the world's first commercial jet airliner, making its first flight on July 27, 1947. A new age in passenger travel was ushered in when BOAC entered the aircraft into service in May 1952. It was a great source of pride for the United Kingdom, which was lagging behind in commercial aircraft development following World War II. So in this video, we are going to talk about the de Havilland Comet, the world's first commercial jetliner. The video is going to be amazing, so make sure you stick to the end. When the first prototype was flown, it was immediately apparent that the type would set new standards for both flight performance and passenger comfort. The de Havilland Comet, which was built at Hatfield, some 30 miles north of London, was a groundbreaking piece of aviation history. Alastair Hodgson, the curator of the de Havilland Aircraft Museum, says that the de Havilland Comet made everything else obsolete by flying higher and faster than any other aircraft at the time. Only 36 passengers could be carried aboard the Comet, which had a smaller seating capacity than what we've come to expect from modern jetliners. It was packed with new technology, but perhaps most importantly for those early passengers, it was a quiet, luxurious, and even pleasant experience. Something that could never be said for the noisy piston engine aircraft that came before. The de Havilland Engine Company Limited produced 4 Ghost turbojet engines for the aircraft. Ghost's original inspiration came from the de Havilland Goblin engine, which powered the de Havilland Vampire and the first Gloucester Meteor. Due to its extended service intervals and simple construction based on Sir Frank Whittle's early designs, the Ghost was well suited for civil usage. Before we move on, support us by hitting subscribe and the bell icon to get notified when we post new videos. Now, let's get back to our topic. The airplane, with a range of 4,000 kilometers, could transport 36 people at a speed of 700 kilometers per hour. 450 miles per hour. For ease of training and fleet conversion, de Havilland designed the Comet's flight deck layout with a degree of similarity to the Lockheed Constellation, an aircraft that was popular at the time with key customers. The cockpit included full dual controls for the captain and first officer, and a flight engineer controlled several key systems, including fuel, air conditioning, and electrical systems. The navigator occupied a dedicated station, with a table across from the flight engineer. Several of Comet's avionics systems were new to civil aviation. One such feature was irreversible, powered flight controls, which increased the pilot's ease of control and the safety of the aircraft by preventing aerodynamic forces from changing the directed positions and placement of the aircraft's control surfaces. A pressurized refueling system developed by the Flight Refueling Limited allowed the Comet's fuel tanks to be refueled at a far greater rate than by other methods. The aircraft's weight and fuel consumption have to be maintained to a minimum in order to accommodate the greatest number of passengers and cargo possible. Utilizing a combination of old and new building methods, the structure was built using rivets and a process called redox bonding. With all its glory, the Comet sadly had devastating accidents in January 1954 near the island of Elba, and then 3 months later when another Comet disappeared near Naples. Both aircraft had departed Rome. Investigators from the Air Accident Investigation Board (AAIB) found that there was catastrophic failures of the pressure cabin due to metal fatigue. The passenger windows on the aircraft were square, and the cyclical pressurization and depressurization of the fuselage accelerated the stress levels around the corners, causing fractures in the structure and almost instant failure of the airframe. Also, the thickness of the aluminum fuselage was similar to that of a credit card. A previous Comet accident in 1953 near Calcutta attributed severe turbulence as the cause of the crash and was not related to the Elba or Naples disaster. With the structural problems identified in Comet 1, they were all withdrawn from service and the production line at Hatfield was halted. The damage was big to the Comet name and it was never able to regain its previous commercial success. Though the de Havilland Comet served until 1981, there were 4 versions of the aircraft. Even though the Comet's story ended tragically, the plane's design and look had a significant impact and helped lay the road for modern air travelers' enormous success and popularity. Paul Wivey, professor of casting at the University of Birmingham School of Metallurgy, states in a video presentation delivered in 2019, analyzing all available data, that the fact that de Havilland put oval windows into later marks is not because of any squareness of the windows that caused the failure. De Havilland went to oval windows on the subsequent marks because it was easier to redux them in use adhesive. Nothing to do with the stress concentration, and it's purely to remove rivets. In responding to the report, de Havilland stated, "Now that the danger of high-level fatigue in pressure cabins has been generally appreciated, de Havilland will take adequate measures to deal with this problem. To this end, we propose to use thicker gauge materials in the pressure cabin area and to strengthen and redesign windows and cutouts, and so lower the general stress to a level at which local stress concentrations either at rivets and bolt holes or as such may occur by reason of cracks caused accidentally during manufacture or subsequently will not constitute a danger." So that's it. Please like, share, and comment your thoughts below if you like this video. Remember to subscribe to see our next video. Stay safe, and we'll be back soon with another video.